Okay, today I'm going to cover, or for some of you is just a reminder about the concept of pointer in C or C++. Okay, this is what I try to do. So there is a big difference between a typical programmer of other programming language, like, for example, Python or Java, versus a C or C++ programmer. I would say, if you ask me what's the major difference, the major difference, I think, is C programmer need to have this or similar kind of computer architecture hardware picture in mind. So the difference is that when you look at, this is called motherboard with CPU, with memory, with all kind of interface. You can connect it to a network, connect it to a hard disk, connect it to your monitor, for example. So C as a language originally was written in managing all this device. So there is a lot of, I would say, the language construct enable you to do a lot of this kind of flexible thing, all right? I mean, later you learned about the concept of operating system kernel, you will see how exactly all this match. So today I just want to tell you about the pointer part about this language, which will affect the C++ as well. So among all other things, the most important thing is here, sometimes we call memory bank. So essentially, in other programming language, when you allocate an integer, when you allocate an object, you allocate an array, you don't really care where that memory will come from. You probably will care if it's too big or too small. You can actually do something like that. But C, as a programming language, it actually gives programmer more headache or more power to managing to access that perspective. So that is why you actually need to understand the concept called memory bank, and later I will refer another concept called memory cells, meaning that where is this particular things arrive? Okay. The other thing I should actually tell you, maybe I jump ahead this and then come back a little bit there. The other picture you might want to have is this picture. This picture may be overwhelming, but is a really accurate system picture about where your memory. I talk about memory bank, right? And the thing is that in all other language, you actually don't know where the memory currently is. Where is your integer? Where is your object thing? Where is your object, person? And where's the inheritance to do with this all this memory? But this picture actually shows how your memory got really allocated. So I want to move this down a little bit because let me.
Would you be able to go over R and L values as well? Because L values and R values is the related to memory.
We'll talk about that, maybe not today. Okay, yeah, because I have to clarify with you exactly what you're looking at, but I might be able to cover that. I just don't know. Okay, let me hold on to that. Okay, so I get rid of that so you can see the whole picture. So this is the allocation of the memory address. So this is a memory bank, but you have each of the memory. I kind of look at different regions. I will explain only some of them to you, but there's a few things that's actually critical. So the memory address, starting the lowest address, this, if you see, this has a decimal, and with a character has decimal, so this is represent a 32-bit architecture. So addressable is 32-bit. So your memory address is 32-bit. I mean, right now, we're gradually shift everything to 64-bit, and the picture is still the same. in terms of the relative position. Okay, so what do you think is the smallest memory address that you could ever have? What should be the address smallest? 0000080, right? 0 supposed to be the smallest. Take a look at this picture. What is the smallest address that we actually design in the system? What is the memory address we have? 100. It's not 0000000. Why is that? Why I didn't start it with 00000000?
The first few bits are fixed.
Because the design of the system knows about the problem of C programming. The C programmer, the most serious crime a C programmer can commit, guess what? Segmentation fault. Yeah, you have experienced segmentation fault, right? So what is a segmentation fault? You dereference a pointer, you never allocate, you never malloc, and you dereference that. You define a pointer, and then the pointer initialization for most of architecture is null. Null means 0. And you forgot to do malloc, and you directly start to dereference that pointer. Guess what? The system actually have a perfect mechanism to deal with that because I actually reserve 0000000 to deal with that detection very easily. So anybody try to touch that memory is prohibited. And immediately segmentation will come up. Yes. Dereferencing is, let me actually tell you what dereferencing is. If I write a code, looks like, let me check. Let's see, do I have a dereference code very easily? Yeah, I have too many of this ugly code. So let me show you a piece of code. Okay, for example, if you see anything that this is, this is ugly, this is an array representation, memory representation array. But this is a pointer. If this is a pointer, you put a star. That means you're dereferencing. Okay, I know what do I mean by dereferencing? I prepare this. I always like to teach this when I teach pointer. So this is a one memory cell. I'm not going to put an integer. Pick a point integer you like. 12, okay. So I put 12. This is the 12 content. And just let you know, I'm giving to you because you're my memory cell. You think 12, okay? And your memory cell, so you have an address. Let me put your address as a 0x. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so he hold on the content that Ammon is holding is 12. But the address of Ammon is this 30 to the integer. Okay, so this is I put it with Ammon. Okay, now you're a pointer. Okay, what's your name again? Kevin. Okay, so Kevin is a pointer. You're the good kind of pointer, okay? So what is a pointer? Pointer is 8 byte. And the thing is that when I assign the pointer to Kevin, Kevin's value is all 0. Kevin, what's your address? You said there, I know that has a memory address I assigned 3 years ago. I still remember that. That one is A7654321, okay? So this is a memory address. And the thing is that I'm supposed to, let me actually try to dereference, is that now Kevin is, can you hold this? No. Now if Kevin wants to actually reference to that 12, what he needs to do is you do a star Kevin. Okay, star. Kevin is a pointer. If you do star Kevin, it's called dereferencing. So the dereferencing is suppose that the content of Kevin, not 12, the content of the Kevin should be 1, 2, 3, 4, 5, 6, 7, 8. The content of Kevin should be like this. But I forgot to do that. Or I forgot to even allocate. So Kevin, can you raise up your paper? So you can see that Kevin's content is still 0. So that was immediately that was what we call segmentation fault, because why? You go back to this picture, you try to access the memory, that's actually out of range. The minimal address that you can have is 0001000. So immediately you access something which is lower than that, you got a signal, you got a segmentation fault. Okay, so dereferencing is okay, you use this address, so Kevin can do this. So now I'm actually doing this correctly. I malloc Amen, and now Kevin has an IP address assigned to that. And if you do a star, I use a different one. Let me tell you how you can dereference a pointer syntactically. Is just star 0x12345678. If I say star, put the star in front of the content of Kevin. This is dereferencing from the pointer. And star 1234, the way to interpret is I'm treating this as address. I want to see the content. So this address will help me to read to Amen, because that's Amen's address, and star will lead me to 12. That's how I actually begin to do the referencing. Dereferencing, sorry. Reference means that I'm actually accessing address. Dereference means that using the star of that address, I can actually retrieve the content. Does that sound okay? All right, so we're going to see some example, but this is I already used this simple example to tell you what address. So let me actually put a more complicated stuff. So sometimes you say character star star, since I'm already here, okay? Who want to be another volunteer? Maybe you in the bar. What's your name? Tyler. Tyler, okay, I'm going to use Tyler. So Tyler's address is a 0x, let me see, 9A001234, okay? And Tyler, pick a number. 42. 42, okay. The content of Tyler is 42, but Tyler's address is 9A001234. Tyler, you hold that. Okay, so if I actually define, I'm actually going to change the content. The content is no longer 12. I'm actually going to set the content to be for Amen to be 0x9A001234 as the content of Amen. Amen is still in this address, but the content changed. Okay, now if I have the star 01234, I add another star. 2 star, I dereference twice. So what does that mean? Kevin has the address, has a pointer, the pointer has dereferenced twice. So the first time I go to 1, 2, 3, 4, 5, 6, 7, 8, whatever, I almost forgot. And then that will lead me to Amen. For the Amen, I have the second star. The second star, I look at his content as a pointer. So now this leads me to Tyler. Was that 42? Is that right? Okay, so you can see that this could be complicated. So it's a pointer to pointer to pointer. I mean, it's once you get used to it, you kind of start to love it, but that only take me a short period of time. Like 30 years of C programming, I still hate it, just to let you know, okay? So it is basically like that, all right? So now you know why it's complicated, because you have to remember there is a memory bank, and then there is a address in the area that's actually starting not from 0, okay? It is actually from 000100. Why is 100? Just tell you a little bit technical, because I'm an operating system kernel geek. Okay, so the thing is, I'm skipping one page. One page of memory is for 1 KB. So I'm actually skipping the first page, because the other concept, today's modern technology, memory is called virtual memory. It's called virtual address converted to a physical memory. So this is actually what we call virtual memory address space. So virtual memory address space means that I actually can allocate a huge amount of memory, but my real memory is actually very small. So sometimes you bought a phone with say 4 gig memory, sometimes you bought with 12 gig, but you can run exactly the same system. It's because virtually it all allocates to the same amount of memory for the mapping. So in other words, I'm saying I skip one page of virtual address is perfectly okay. It's not going to hurt my memory at all. Okay, so just let you know that that's actually, hopefully you start to connect the dots about things going on. All right, so before I leave this picture, I want to show you two memory areas, which is very important. So one area is called user stack, and one area is called heap. So you can see there is a, by the way, the top of this part is all operating system kernel. You're not supposed to touch that. If you actually, as a user program, you try to dereference that area, you also have segmentation fault, just let you know. But there is some area in the middle that's actually called user stack and the heap. And you see the arrow? So the user stack rolling down where the heap going up. So where's the user stack? User stack is when you actually make a function call. It's actually allocate your local variable. You define a function as a local variable. Those local variable and the argument to a function, say you call a member function. And that member function has argument, has some local variable. Those variable will be actually put it on the stack. So for example, you have a function called main. Main call another function called scan address. And scan address call another function called scanf. So essentially, the user stack is like you calling, then you grow in that direction. When you return back. So what does that mean? If you think about that, I have main called the other function, and then I actually call the other function. So when I finish this function, I actually return. So this memory is gone. And I call another function, then I over there. What does that mean? Means that if your local variable or argument, when you exit the call, the memory got reused by somebody else. So that's why when you call a C function, you define anything within the scope of the function. Once you exit, that content is gone already. All right, that's actually the area called user stack.
Did I like forcefully access the stack heap where the operating system code is? I know we get a segmentation involved, but if I want to access that using C, is that a possibility?
Whenever you touch that, because there is something called page table. Yeah. The page table will associate with your privilege. So if the operating system is actually being implemented correctly, then if you are a user mode, you cannot access. But this is I'm not teaching ECS 150, so I have to be careful not telling you too much about that. But basically, when you actually try to use kernel space, you have to use a mechanism called software trap. Software trap means that you actually give the control about user program to the kernel. Then you can actually access the memory. And then if you want to do something, is from the kernel, put the write back to the user space. So kernel always get right back to the kernel space.
So you just ask the kernel to do whatever you want.
Right. It's called system call. It's going to call system call. Yeah. I mean, later you will learn, hopefully, the glorified detail about all this. For example, Windows XP is, I still remember because I taught that 75 million lines of code, C code, and to do a lot of this. Okay, so the other part is called heap. This part is important because stack is going in and then just vanish when you exit the program, but the heap is going to stay forever. So when you do malloc, that's why when you do malloc and free, or you do new and delete, and those are the memory areas as you get from the heap. Okay, the other area I should tell you that there is a one part called initialized data. This is for global variable. Okay, for global variable, you put it here. For local variable, you put it in user stack. And then for all the malloc and free is actually in this area. Oh, sorry, malloc and free, yeah, is in the heap. So the thing is, you can see that that's why when you call a function, you return, your data still exists. So for example, when you do malloc, I use Kevin's example. Kevin, can you raise your pointer again? That pointer, yeah, that pointer, whatever 0A7 is actually Kevin call a malloc into an address, probably in this area. And then the return of the malloc. So let me tell you, the first step when you call malloc, you try to find a space here. And that space happened to be A7654321. And then it returned the address to the call. So your program now is called Kevin is a pointer. Now Kevin actually hold the address. So what does that mean? If you return this address to another program or another variable, then essentially you have the access to a piece of memory in your system, even if your function exits. Okay. So this is if this is the first time you heard about this, I know this is kind of could be overwhelming, but this is sometimes I feel it's the best way, the most painful way to understand pointer is actually really understand the machine, understand the hardware, understand there's something called memory, and there's something called your operating system is actually managing the memory this way and to help you. Yeah, please.
So this is the address that you as a pointer have, or I as a pointer have, and then is this the address or that I point to as well? Or like, because this is the address of my phone.
Okay. A7654321 is your address. And the malloc return is 1, 2, 3, 4. So in other words, if you're a function local variable, if Kevin is a local variable, then that A765 is somewhere in the user stack. Because I actually have a, say, character star Kevin. Character star Kevin is actually, that variable is in user stack. So it's actually transient, temporary, it will be gone. But when you do malloc, you allocate a space, then 1, 2, 3, 4, the other one, which is the address pointing to Amen, is actually going to be on the heap. So you understand what I'm saying? So each of this has an address. You see that? Each of this has an address, starting from 0, whatever. So this one, this area is 1, 2, 3, 4. That's his address. It's not going to be wiped out when function exit, but your address is here. The Kevin pointer is actually the user stack in this example. So think about address. In programming, you have to use data, right? You have to use data. The data has to be stored somewhere in this memory bank. And that memory bank has to have an address. So that is the association. You have to, the difference between a C programmer that required to know is this is a concept called address. When I use any data, it's not just the data itself, not just a variable name, but the address is going to make a difference as well.
So when we use malloc, are we allocating memory to point us to the other memory also? Or are we not?
Well, when you call malloc, you're actually calling a library function to find some space that you need in this memory, in the memory. And I'm actually, if I'm the malloc program, you ask for malloc for 16. That means you want to allocate 16 bytes of memory. So I will have algorithm going here to find 16 bytes. I have my own memory management. Programmer doesn't have to worry about that. So I found 16 bytes, and I actually will return to the caller the memory address of the first byte. So malloc program always return the address of the first. By the way, malloc you can allocate 4 byte, 8 byte, or 2 million byte, or 2 terabyte. You can actually allocate as much as you want. Yes, please.
My question is about Heap. So if, let's say, someone constantly does malloc and then he forgets to
Free.
do it,
Right.
right? So can something actually happen? So I assume that there is no garbage collector or something for Heap.
For first.
So can you
encounter this situation where your memory is actually unusable because like you forgot to delete it.
This is so commonly happening. Thank you for asking. What's your name?
Yeah.
Dennis. Okay. What Dennis just raised is the second most serious crime in C programmer. It's called memory leak. What is a memory leak? Memory leak means that your program does not free the memory correctly, and such that eventually used up all the memory over here, and such that your server will crash. So this was actually one of the most commonly problem with all the server. So I'm a server, I'm actually receiving all the HTTP connection, I'm helping every other people. If you think about YouTube, if YouTube, for every single request to YouTube, they forgot to free 4 bytes, just 4 bytes. You can imagine how long that the server will crash, right? Because it used up all the memory. And it's a bookkeeping I used up, so then it crashed. So that's actually one of the problems that people criticize C. Because C programmer, you really have to do very careful, this kind of memory management, especially if your program is going to run for a longer time. I mean, for your program right now, I actually didn't worry too much because your program is going to run in 1 second. There is no way that you're going to run into that memory leak. But later, I will show you some of the program that's actually so easy. You just run for about a few hours, you're running out of memory. And then the system is going to give you like a segmentation fault or bus error. Why? Because you no longer can do more. Yeah, that's a very, very common. I mean, even myself in my career, I probably spend 30% of my time just debugging memory leak. And it's hard. I mean, the tool is, we used to call a tool called memory debug that help us to actually managing the detail about the heap. It's just so tedious. Sometimes it's just happening in a way that's actually so tedious. It's really, really hard for us to track. I mean, sometimes it's not my code, it's other people's code. 45 million lines of code. Okay, good question, Dennis. Yeah. Any other question? Okay, so this is a system perspective. I hope I give you enough for you to kind of understand what kind of the system or what kind of situation we're dealing with. Now we're going to go into programming. But how do you actually represent this concept in programming? Okay. Okay, so the first thing I need to show the address. Well, I have a memory box in this example. It's actually going to store the mile. And somebody is going to put the 30.5 into that. Well, how do I actually write that? The code looks like this. The code on the top. I use a scanf, right? So what's a scanf? Scanf is saying that, hey, I want you to enter a number. And I'm going to put that number into some memory location. That's what really scanf is doing, is I want you to tell me where I should actually put the data you just entered. Is that fair? That sounds fair, right? So the first part is what we call format string, the double quote %LF. This is basically given the scanf program about how I should interpret the number you just type in. I mean, for example, if I type 20.5, if I type this number 20.5, I can actually interpret 20.5 as a floating point. I can also interpret 20.5 as a string, right? That could be a string, 20, a period 5. That could be a string. So therefore, sometimes the system needs our clarification about whether that's a number or it's a string. That's why I actually have to put %LF to actually say this is a long floating point or double, essentially. So this actually is a communication. I have to tell the system. This is called format string. And then the second parameter is the address. Remember, I said, okay, I'm going to bring in a floating point, but I'm going to bring in the memory address, so you can put in. So now here is an interesting part. You see that M sign, I put it in front of mile. So mile is what? Mile is the variable. If I say double miles, then essentially I put an M, that means it's actually the address. So anything you have an integer, for example, I define something called integer I, and I put an MI, that means an address. So let's use Kevin's example. If I say, if I say Kevin is going to be 0x12345678. If I say M Kevin is going to be, what's the other address? A754 4321. Okay, so that's the difference between N is always reference to the address. So that's why if you have an N, then you know it's no longer the content. In your case, 12 is actually switched to the address. Okay, it's very, very, very important concept over here. Okay, I hope you understand this. And then we have a 32-bit versus 64-bit. I'm not going to go into the detail, but essentially what I'm saying is that if I'm actually going to put into a double, a long floating point, and typically in modern system, that means 8 byte. Today, if you have a double means double precision floating point. If you have a double, then that's 8 byte. So just like a malloc, the same interface, I'm actually providing that N miles, I give this address 0x, the first byte of the address. By the way, the following two programs are exactly the same. I can write a program that way. I can also write a program this way. These two programs are equivalent in C. That is looks nice. It says it's a miles N, but for some reason, I already know the address of that miles, N miles. I can just directly enter the address. This code actually will work.
What happens if I remove the ampersand?
If you remove the ampersand, most likely you're going to get segmentation fault.
Even though miles is a variable? And I'm like, okay,
Because
assign-
miles, what's the content of miles, right?
Say if when I declare, I assign it to 0.
Right, with 0, then you actually go to SSM, because now if you don't have the N, okay, can I use your? So suppose the address of Amos is this here, this address is this address. Okay, so suppose that should be over there. But if I forgot the N, it's going to be say 12 or 0. 12 and 0 doesn't matter. Both of them actually will be the first page. If I have a 12 and I try to dereference 12, right? I try to store the number you just type in. I try to access the memory 12. That's prohibited, and that will cause segmentation.
So every time I wanna get an input, user input, I have to use an ampersand. I have to give
You have to use either ampersand or you have to use some kind of address as a value. In fact, just like you know, this is a horrible concept. I have to say that in C, it doesn't care what's the type of the variable. It cares about how whatever you put in, it translates to a value that's actually need to be equivalent to this. Okay, so C is a very weak type language. It doesn't check whether you can put integer, you can put whatever bizarre things. As long as eventually it translates into that address, is the address correct? You're okay. Yes, please.
So if miles was a pointer to another variable and you put just miles, what percent would you be putting the 30.5 into that variable as percentage?
Right. Okay, that's a good question. We are assuming miles is a double, right? That's what we use ampersand. If miles is a pointer, then you should just put miles without the M sign. Yeah, you should. If you put M sign, then you essentially override that pointer, right? You actually override that pointer. Yeah. So okay. If you saw some of my program, sometime if this is a pointer, I like to write say miles underscore PTR, because I want to kind of declare that I intend to use this variable as a pointer, so I won't confuse myself. Yeah, you have a question.
Yeah, so my question is, does C somehow understand that this number is a pointer and this number is not a pointer? So let's say
No,
we
it
have
doesn't.
like,
It doesn't.
so then does this mean that if we just randomly plug in here instead of miles, not its actual address, but some like large random integer, and it will try to assign this to this?
Right. It will do that. So that's why actually C is pretty dangerous. There is a lot of cybersecurity attack is leveraging that feature. Because C doesn't check at runtime. In compiler time, they might check something. But even in compiler time, I use casting. I can avoid a lot of things. I can still do what I want, whatever I want. And C sometimes is very, you can actually write this piece of code sometimes. Is I have a variable, I actually add 5. And then I use that number as an address to do that. You will see how I actually do that in a very commonly way. Yeah. Yeah, so answer your question. C language, they don't really differentiate integer and pointer. It doesn't even defer a double from a pointer. If you want to use that as address, C will allow you to use that. Okay, any other question? All great question. I love all your questions. Okay, so let's actually just memory box. I think you already know this, so I'm actually going to just a program, a useful program, not so much with the pointer, but it's a very important program called size of. It's a function. Is trying to understand that this particular type or this particular variable, how many bytes, because different machine, you will have different size. For example, the first machine I have integer was 16 bits, and now integer in the modern systems at least 32 bits. Some of this already went up to 64 bits. Okay. Okay, so I think you have this part. Okay.
So integers are 32 bits, right?
What?
Integers are 32 bit.
We don't know. We actually don't know. You have to test it.
But we say it's guaranteed that it's at least 14 bits. Well, we cannot guarantee that it's 32, but the guarantee is that it's at least 14.
I will say there is a practical issue and theoretical issue. We still have to be careful because some of the machine is embedded system. It's really I will say it's not old, but they want to save the space to save the machine. So some of the embedded system is still very small. So they could have a design that actually integer is a lot smaller. So for example, I think some of the processor, okay, I remember this is in year 2000. I actually helped a company develop a Bluetooth. That was the first generation of Bluetooth device driver. At that time, we're using a microprocessor that's only 8 bits. You think about that, this is 2000. It's already a 64-bit computer available. And we actually want to save cost because that was an ASIC design. And that 8-bit processor, we don't have to pay any patent. So we just use 8-bit to build into ASIC. Yeah. So in an 8-bit computer, the address is only 8-bit. So I don't expect integer to be 2-bit. It's probably 4-bit or 8-bit. Okay. Yeah, but that's sufficient for Bluetooth. Yeah. Okay, so now we're going to look at the code. All right, so this is the code that how I declare a pointer. So there is a data type, and then there is a star, and then there is a variable name. For example, I said integer star Kevin underscore PTR. That means I declare Kevin underscore PTR is a pointer to an integer. Okay, that I just declare. So let me tell you that a pointer, let me ask you, assuming I run the code size of, I really want to copy this code. Sorry, let me actually try to copy this code. Let me copy this code. You can see this, right? Okay. Next, say size of the C. Okay, let me just do this. Okay, good. I have this piece of code. And now I'm actually going to do is that I'm going to adding this 4 line to another 4 line. And what I'm going to do is add a star here. I think this will avoid any trouble. Okay, so I want to show you the first four line of the code. I show you it's a size of a integer, floating point, double, and character respectively. And the next 4 lines are basically the size of pointer pointing to an integer, the size of the pointer pointing to a floating point, the size of pointer pointing to the double, the size of pointer pointing to the character. Let's see the result. See, in computer programming, we really just want to compile the program and get it to work. And then we can see the result. What? It's a warning. That's okay. It's a warning. That's probably want me to use LU instead of D, but that's okay. Okay, so you can see that the size of an integer is a 4 byte. Integer is a 4 byte. In my system, the integer floating point is also 4 byte. The size of the double is 8 byte. The size of the character is 1 byte. But the size of pointer doesn't matter. It's an address. It's all 8 bytes. So which means that my machine is a 64-bit machine, right? So that makes sense. So I want to tell you that pointer is address, and addresses doesn't matter, is the size of the address. Okay, it's always 8 byte. Just want to tell you that it's very important for you to know this. Okay, so let me go here. Yeah, I want to come this way to tell you a few things. So now we're looking at the syntax. So if I define type star, by the way, pointing to object is also 8 byte. So person star, whatever, person underscore PTR, or you can say Felix underscore PTR. That's the way you actually declare this line. You declare the pointer. So now I'm actually show you the example. The first one is integer x. That means it is an integer. It's a variable. It's not a pointer. And the second one, I actually declare something called XP. Means that it's a pointer. XP is probably a pointer to X or something like that. And so that's why I define a pointer. And then when I define a pointer, by the way, when I define a pointer, I haven't given the address. So that pointer is actually 0. Usually it's 0. By the way, even this is not guaranteed. I have seen some of the machine. It's not guaranteed that if you don't do any kind of initialization, it's give you a random value. I have seen this kind of system. Sometimes that's why I personally got hurt, because I have a program run perfectly on one platform. When I actually port it to another platform, it suddenly has bug, and I don't know why. And then I spent a lot of time realize that it is actually I need to initialize. Okay, well, I remember what happened last year when I taught the course. I think in Mac OS C++, when you actually declare an object, the constructor, you don't have to set everything to be 0. It's automatically all the variable you created becomes 0. But Linux didn't do that. So Linux actually giving you random value. So that's why constructor is important. You actually want to set it to be 0. And I realized that I have to set it to be 0 in order for the program to be working. Okay, so just let you know that. So after I declare this, XP could be 0, could be some random string. So that's why the third line is important. I actually assign the address of X into XP. So I assign MX. So assuming X is Amon, and MX is Amon's address, 1, 2, 3, 4, 5, 6, 7, 8. And XP is Kevin's pointer. And Kevin's pointer, currently the content is 0. So I use the third line to actually write that address to Kevin's content. So now Kevin is a pointer with a valid content. I can actually connect to Amon.
In C++, when we declare pointer and we assign it to null pointer, so that null pointer in actuality just the address of the first slice was just a null, right?
If you say
Null
null
pointer,
in C++, it's basically 0.
What about null pointer? Because there's a null PTR, a null pointer, and
Null pointer is a 0. It's actually 0. Null pointer is supposed to be 0. If you use that pointer, you're going to get, if you try to dereference that pointer, it's going to give you segmentation fault.
what about null? So
Null is also 0. Yeah, I mean, you can try, but yeah, I mean, it's fun sometimes to intentionally cause some segmentation fault to your system. Yeah.
So the pointers always point to or store addresses to that.
Pointer can point to anything. So think about pointer is just an address somewhere in that memory region, right?
It has to be an address. Or it should be.
Well, but think about this. Okay, that's a good question. Kevin's question, does pointer always pointing to address? And I want to ask you, what is address? Dennis asked me a question. Does C actually understand the difference between an integer, a floating point, and an address? It doesn't. So it's not about what you put there. It's about when you interpret that as an address, which means dereferencing, whether that address is the right place for you to dereference it. Yeah. So it's not a compiler issue. It's become a runtime issue. So in C, there's a lot of runtime headache we have to worry. Okay. Yes, please. Okay, so I don't have a lot of, I'm already run out of, I want to actually say that I assume you understand this, but I actually want to tell you the other thing, which is, I probably should continue this next week, but I just want to give you something to actually panic a little bit over the weekend. Okay, I'm a horrible instructor. Sorry about that. So there is a third concept in C is equivalent to pointer. So not only I cannot tell whether this is a pointer, this is the address, this is the integer. I cannot even tell whether this is the address or this is the integer, or maybe it's an array. In array in C is actually mixing. For example, I have a 3-dimensional array. Let me tell you that how I actually do the array. You typically in the programmer, you actually write array looks like this. You declare the type, declare the name, and put the size. If you have a multiple dimension, looks like this, okay? But the thing is that the compiler essentially converted to this format. So essentially, when I calculate, when you want to access the array, I'm actually calculating M represent the first byte address of the array. And I calculate the size of your column, I time it, and plus Y. So essentially, internally, I'm actually calculating the address of your array, the address of the element of the array you want to access. When you want to say M, X, Y, really is just stop, just dereference of that pointer. You think about that, it's the same thing. Array and address is the same thing, because as long as you want to do memory address, sorry, you want to do matrix or array, that's just a programmer impression about what's happening. But internally, the system still have to find where that address is. And that's why everything being converted over here. By the way, this is the valid code. In C, if you're really, really bad, you can actually write this code like this. You don't have to do this. This is much more readable, but I forgot the reason, but sometimes I have to write the code looks like this to do some kind of handling myself, okay? All right, I probably give you enough things for you to get started. We'll continue this a little bit, and then I hope after that, you're good in Pointer. Hold on 1 second, let me turn off the recording.